परफेक्ट इलेक्ट्रॉनिक्सचे संपूर्ण ऑटोमॅटिक ऑटो लेक्चर बेल आणि ऑटो राष्ट्रगीत प्लेअर सिस्टीम शाळा कॉलेजसाठी अत्यंत उपयुक्त. उत्पादक परफेक्ट इलेक्ट्रॉनिक्स MIDC वाई. फ्री डेमोसाठी संपर्क 98 222 41 255.
Hi friends, myself Dr. R.V. Dhekale, Perfect Electronics MIDC Y. We have designed and developed Owens bridge for finding the self-inductance of the coil. Now I am showing the demo of the same experiments. Now we shall see the chart of Owens bridge. See, this is the M, this apparatus is given. The formula, two formulas are given here. For DC balance, this formula is given, and for AC balance, this another formula is given. This is the circuit diagram for DC balance. This is the circuit diagram for AC balance. This is the observation table for DC balance. This is the observation table for AC balance. And this is the procedure for DC balance. This is the procedure is given for the AC balance. So see the construction of the Owens bridge for DC balance. Now it consists the inductance of internal resistance of 50 ohms. Now this is the jumper wire is connected here. See, if this jumper wire is connected here, this resistance of 100 ohms comes in the circuit. Now this is the resistance. This is the resistance R1. R1 can be varied. Any of the three resistance can be selected here. This is the resistance R2. Variable resistance R2 is connected here. That potentiometer is used here. This is resistance R3. Fixed resistance is used here, and this is resistance R4. This galvanometer is connected here. The potentiometer is connected here, and DC voltage of 12 volt is applied to the from the adapter. See, I am switching on this. See, galvanometer shows some deflection. I have selected R1 is 100 ohms resistance. Now we shall balance the bridge by rotating this knob of the potentiometer. See, so I am putting this pointer of the meter at the zero deflection. C. Now we shall measure the resistance of the potentiometer by the use of multimeter, by disconnecting this power supply and by disconnecting this port of the potentiometer here, and using the multimeter with the range of 200 ohms. I am measuring the resistance between the 2 points 1 and 2, and see, this is the total resistance is 146.2 ohms. By the use of this resistance R2 and R1, by the use of formula, internal resistance of the inductance can be determined. In similar way, we can select the resistance 220 ohms by the use of this connector here. See, we can balance the DC bridge. See, in this way, again we can disconnect the power supply, disconnect this port, and by the use of multimeter you can measure the resistance. In this way, we can measure internal resistance of the inductance. This is the experimental setup for Owens bridge for AC balance. Now this is the inductance. This resistance 100 ohms in series with the inductance here, and total resistance of this path is 100 plus this 50 ohms. That means 150 ohms. To satisfy the DC balance condition, I am using this resistance R2 as 150 ohms here. Now here the null detector is connected here. Equal capacitors are used here. Here signal generator of 1 kilohertz sine wave frequency signal is applied here. This is the variable potentiometer. Now in order to balance the AC bridge, we have to rotate this part so that we shall get the minimum deflection or zero deflection. See, this is the zero deflections. Then we have to measure the resistance of the potentiometer by disconnecting this signal generator and using the multimeter with the range of 200 ohms. Now I am measuring the resistance of potentiometer between the points 1 and 2. See, resistance is 45.4. Knowing the value of R2, R3 and capacitors, we can find out the value of the self-inductance of the coil.
परफेक्ट इलेक्ट्रॉनिक्स वाई आयोजित 6 दिवसांचं प्रॅक्टिकल बेस्ड इलेक्ट्रॉनिक्स अँड कम्प्युटर इंडस्ट्रियल ट्रेनिंग
पात्रता इलेक्ट्रॉनिक्स आणि कम्प्युटरचे शिक्षण आवश्यक. बीई, डिप्लोमा, बीएससी, एमएससी झालेल्यांसाठी उपयुक्त.
या ट्रेनिंगमध्ये भरपूर प्रॅक्टिकलसह मुलाखतीची तयारी करून घेतली जाते, ज्यामुळे जॉब मिळणं सोपं जातं.
ट्रेनिंगसाठी संपर्क डॉक्टर ढेकळे, परफेक्ट इलेक्ट्रॉनिक्स MIDC वाई. मोबाईल 98 222 41 255.